3. Okay, so when we have two linear equations, meaning equal signs, they're going to have one solution. Today, this is 5.10 in your course. So a lot of you took the 5.9 quiz yesterday. So if you want to start on 5.10 today, you can. There's a quiz for that one as well. But what we're doing today is we're going to find the solution for a system of inequalities. Okay. This is not much different than graphing, and all it is graphing two inequalities. Okay, so it's not much different than solving by graphing just regular systems. Just our solution is going to be a little bit different. So let's take a look at, why is this not loading for you? There we go. Let's talk about how to graph a linear inequality. So remember, an inequality is going to have a less than sign, a greater than sign, less than or equal to, or greater than or equal to. Okay, that's what a linear inequality is. So step 1 is we want to put it in slope intercept form. In other words, solve for y. Okay. Then what is step 2? See if you can figure out what goes in those blanks. Graph using blank and blank. So what do we graph first? If we're graphing a line or an inequality, what is the first point we put on our coordinate plane? Anybody? How would you graph it? Would you just pick a random point? Let's say you had this an equation, y equals 2x plus 1. What point would you graph first? Exactly, Aaron. Very good. Yep, good. The y-intercept. So we're going to graph using the y-intercept and the slope. Okay, so go ahead and fill that in on your paper. Write that down. Okay, these are your steps. So you're going to want to write these steps down so that you can use them on your homework and your quiz. Step 3, decide if the line is blank or blank. What do you think goes in that? Think about inequalities in our signs. We have less than or less than or equal to. What's the difference in those? Anybody? Okay, so if I have a sign, let me circle, that's just less than, what kind of a line will I use? There you go, Jonathan. So I'm going to decide if the line is solid or a dotted line. You guys remember that from graphing inequalities? Okay, and then step 4, with inequalities, remember it's not just an equal sign or 1 point. We're going to shade an entire region, so above or below the line. Okay, I'm going to get rid of this so I don't confuse anyone. All right, I'm going to give you a few more seconds to finish writing down these steps, and then I will have you put your pencil down so I can show you what this looks like without you having to try to do it with me. Okay. So let's practice by just graphing one linear inequality. So step 1 said to solve for y, or get it in slope-intercept form. So I have my y right here. So I need to get this 3x on the other side, and then I'm going to divide. So the first thing I'm going to do is subtract 3x from both sides. 3x minus 3x becomes 0. So I have 2y is greater than negative 3x minus 2. Any questions about that? Okay, awesome. Now I have y almost by itself. It's still being multiplied by 2 though. So what I'm going to do is divide everything by 2. So I would get y is greater than negative 3 halves x minus 1, because 2 divided by 2 is 1, and I still have that negative sign. Okay, so that was all just for step 1. Now that I've got step 1 done, I go to step 2, which is to graph using the slope and the y-intercept. So I'm going to plot the y-intercept, which is at negative 1. And then I'm going to use my slope, which is negative 3. So down 3 to the right 2. And then I can also go up 3 and to the left 2. Liv, good question. The rule for flipping the sign is when you multiply or divide by a negative. We'll probably get to a few of those. We'll look. Okay, so now step 3, decide if I'm using a dotted or a solid line. So I look at my inequality sign. It is only greater than. Okay, so that means I'm going to use a dotted line through my points. Good, Ben. Now I have to decide which side of the line I should shade on. So I always like to use 0, 0 as a test point. Yep, so what I'm going to do is come back to the top where I have 3x plus 2y is greater than negative 2. I'm going to plug in 0 for x and 0 for y. So 3 times 0 plus 2 times 0 is greater than negative 2. So 3 times 0 is 0. 2 times 0 is 0. So 0 plus 0 is 0. So is 0 greater than negative 2? Yes, it is. So that means I'm going to shade the side that contains the point 0, 0. So this would be shading above my line. So that's a quick review. Good job, Ben, on graphing one linear inequality. But remember, what we're talking about in this unit is systems of inequalities. So that means we're going to have 2 graphs together. So let's take a look at what that looks like. When we have 2 inequalities graphed together, we will have a shaded area where they both overlap. Okay, so the solutions to a system of inequalities, the solutions are any ordered pairs in the shaded area. Okay, they have to, it's not just the shaded area for one, it's the shaded area that overlaps. So let me show you what I mean by that. Okay, let's take a look at this one because it's already in y-intercept form. So for this top one, I'm going to put a little green dot. Okay. So we want to find the y-intercept at -2. Here it is. Okay. And then they did -1/1, right? So this line, I'm going to kind of cover it in green. Okay. If I use a test point for this line, we would get 0. If I use 0, 0 here, 0 is greater than -0 minus 2. So is 0 bigger than -2? Yes. So that means this green one was shaded above the line. Okay, so just the green one, the top inequality, was everything above that line. Where did that go? There we go. Now, let's do blue for this bottom one. Okay, so this equation is blue. And if I use a test point for that one, 0, 0, I would get 0 is less than -5 times 0 plus 2. So is 0 less than 2? Yes. So then that means I would shade on this side. So as you can see, our solution set for a system of inequalities, so more than one, is going to be this red here that was originally highlighted. It's where the two shading areas overlap. Okay, this was just leftover green, so that was only the solution set for the first one. This was leftover blue. So the only shaded area that they have blue and green would be here. All right, so I want to see if you can understand just the different highlighted areas first. I'm going to put up a poll. This is just asking about the solution. So which of these points, we have M up here, B over here, and A down here. Which point, M, B, or A, would be a solution to the entire system? Go ahead and choose your answer. Okay, good. Y'all are doing so great so far. Good, good, good. Keep going. We've got 23 of the 50 that have answered. All righty. So, yay, 73% of you, or 19 of you, chose the correct answer, which is B. So let's take a look here at these points. Point M is only in the blue. So you see right here, this equation says y is greater than -x. So this point M is only a solution to y equals -x, greater than -x. Okay. Y greater than -x. Point A here is a solution to y is less than 2x plus 5 because it's only in this red zone. B is the correct answer. B is where the two shaded areas overlap. Ben, I actually don't even know what those are. Sorry about that. So let's do some together. So I want you to graph these with me on your own paper. These two systems already are solved for y, so that is great news for us. All right, let's go ahead and graph the first one, the red one. So we have y is greater than 4x minus 3. The first point I'm going to graph is going to be the y-intercept at negative 3. Then I'm going to use my slope, which is 4. So that is 4 over 1. So I'm going to go 1, 2, 3, up 4 and to the right 1. When we're graphing systems of inequalities, because we're going to be talking about large shaded areas, we want to try to go ahead and fill up the entire coordinate plane that they give us. Oops, I did something wrong. Does anybody know what I just did wrong when I drew this line? Anybody? What's wrong with the line that I drew? Good, Adelina, good. Not the arrows. Yes, Jonathan. So this should be a dotted line. Okay. Because this sign is just greater than. So it's a dotted line. All right, now let's go ahead and use a test point. I like to use 0, 0 as my test point. So I will have 0 is greater than 4 times 0 minus 3. So is 0 greater than negative 3? Yes. So that means I'm going to shade in red the side that contains 0, 0. So that would be to the left here. All of this. All right, now let's go ahead and graph the second line. I'm going to graph the y-intercept first, which is at positive 3. And my slope is negative 2. So I'm going to go down 2 and to the right 1. And I'm going to follow that pattern through. What kind of line will I put through these points? Good, Alan. Good, Jonathan. Yep, exactly. I'm going to put a solid, good, y'all, good, solid line. Okay, now let's use 0, 0 as our test point again. So we have 0 is greater than or equal to negative 2x plus 3. But remember, instead of plugging in an x here, this should be a 0. So 2 times 0. So now I'm asking myself, is 0 greater than or equal to positive 3? What do you think? No, it's not, right? 0 is not greater than or equal to positive 3. So I'm going to shade the side of my blue line that does not contain 0, 0. 0, 0 would be right here at the origin. So I don't want to shade anywhere over here. I'm going to shade to the right of this line. So now is where I'm going to darken in my solution set, which is going to be where the two overlap. So you can see that the red and the blue are going to overlap here, and I'm going to color it in purple. So graphing, it does look like a triangle. Graphing systems of linear inequalities is the same as graphing one inequality. You're just putting two of them on the same slide, on the same coordinate plane. Man, why is this going so slow? Okay, I want to do this one, but do you also see all my writing? There we go. Okay. Do I have anyone? Yeah, it shouldn't be too bad. Do I have anybody that wants to volunteer to graph this top equation? I'll let you put it in red. Does anybody want to try to graph that for me? Awesome. Thank you, Jonathan. I'm going to give you whiteboard tools. And then I'm going to graph this second equation or inequality for us once Jonathan is finished. So Jonathan's going to do it on the board for us, and he's going to shade. And y'all are going to do this on your own paper. Good. And then go ahead and use a test point. So you can use 0, 0, and go ahead and shade one of the sides, either the left or the right side. But greater than or equal to. Good, Jonathan. Talk about how did he get to that? How did he know which side to shade on? So in order line, I like to use 0, 0 because it cancels a lot of things out. So 0 is greater than or equal to -5 plus 3. Ask ourselves, is 0 greater than or equal to 3? It is not 0, 0. All right, now I'm going to show you how to graph this next one. Notice we don't have a slope here. Okay, so this says that all of the y values are greater than 2. Negative 2, sorry, greater than -2. So that means it does not matter what our x value is going across here. The y value is always going to be greater than -2. So this is going to be a horizontal line at y was -2. It's a dotted line because it's just greater than, okay? And then I'm going to shade the y values greater than -2. Exactly, Jonathan. So I'm going to shade the top. And then just to make it a little, like stand out a little more, I like to go back over and either like super darken in, or in this case, I'm going to use a different color. This purple quadrilateral looking thing is going to be our solution. Okay, any point inside this is our solution. Questions so far? Good idea, Ben. I'll do that. All right, let's do another one. Let's do one where you have to solve for y. Here we go. All righty, so let's, I'm going to solve for y. The top one, I'll do that work in red. Okay, so tell me in the room chat, what's my first step going to be here? I'm sorry, Zachary. I know, I'm like lagging super bad today. Okay, so before we use a test point, we only use a test point when we are, like we've already graphed our lines, okay? I'm sorry, guys. We need to solve for y. The steps that you wrote down, or hopefully wrote down, step 1 said put in slope-intercept form. So I'm going to do 4x. Here's my original equation, inequality, I guess. It's not an equation, inequality. I'm going to subtract 4x from both sides. So I would get 3 times y is greater than negative 4x minus 6. The reason that I cannot combine negative 6 minus 4x is that one of those has an x variable, the other one does not. Okay, so I just have to leave them as they are. Alrighty, now I'm going to do one more step, which is divide everything by 3. So then I would get y is greater than negative 4/3 x minus 2. All right, let's go ahead and graph that. What am I graphing first? Yeah, Erica, let me give you rules. You're right, Jonathan. We are going to graph the y-intercept first. Okay, Erica, you should be good to go.
Can you hear me?
Yep.
Okay, so for the first step, we just do the top equation, and then we graph the top equation. Is that correct?
Yep, that's all we've done so far. Yep, so this says to graph and solve. So graph means you're going to graph both of these inequalities. So we have to do one at a time. And then solve is just you're finding the shaded area that they overlap. Yep.
Okay, and when for the shading area, so when the point where it overlaps, what part do we shade? Do we shade like in between both the lines, and that's where you shade it at? Or we shade
So you shade whatever has both shading. Like you're going to shade for this one, we're going to shade either above or below the line. And for the next one, we're going to shade above or below, and then you're done. So for instance, on the ones that we have already done, let me see if they'll pull back up. Okay, so for this one, I shaded the red line on the right-hand side. I used 0, 0 as a test point. The blue one I shaded above. So they already overlapped each other. I just highlighted it more in purple so you could see that the solution to this system is the purple area.
Okay.
Okay, so let's go ahead and we plotted -2 as our y-intercept. Then we're going to use our slope. So I went down. Oh, I did not go down 4, did I? Down 4 and over 3 would be a little bit off the graph. And then since I went off the graph, I'm going to go the other way. I'm going to go up 1, 2, 3, 4, and to the left 3. I'm going to put a dotted line through this. And then I'm going to go ahead and do my test point, which is 0, 0. So I'm going to do 4 times 0 plus 3 times 0 is greater than -6. So is 0 greater than -6? Yes, it is. So I'm going to shade the side of this red line that contains 0, 0. 0, 0 is right here. So I'm going to shade everything over here. All right, now in blue, let's go ahead and put this one into slope-intercept form. So I want you to go ahead and do that on your own. Oh, sorry, we can do yellow. That's fine. Sometimes it's hard to see, but that's okay. We can totally do yellow. But I want you to do this one on your own. And tell me what you get for the inequality. So all you're going to do is solve for y first and tell me what you get for the inequality. Okay, so I'm going to give you a couple seconds to do that. We want y all the way by itself, so that there can't be anything next to it. So I'm going to do the first step here. We're going to subtract x from both sides. -3y is less than or equal to -x minus 9. What's my next step going to be? Divide by what kind of a 3? -3. So let's divide by -3, everything by -3. Oh, good. Okay, so when I divide by a negative, what happens to my inequality sign? It's going to flip, right? Yeah, it's going to flip. Okay. So I flip my sign. Doesn't become positive, it just flips the other direction. Just talking about the inequality sign. But your slope, so we had negative 1x divided by negative 3. That is a negative divided by a negative, which does become a positive. So that would be 1/3 x. And then I had negative 9 divided by negative 3, which would be positive 3. Questions so far? Okay, let's go ahead and graph this one then. Nope, you only flip it when you multiply or divide by a negative number. If you multiply or divide by a positive number, you can leave it. All right, so I'm going to put my y-intercept at positive 3. And I'm going to use my slope, which is up 1 and to the right 3. And then I'm also going to go down 1 and to the right 3. What kind of line will I put through these points? A solid line, exactly. Okay, so draw my solid line. And then I need to use 0, 0 as my test point. I'll do that up here. So 0 minus 3 times 0 is less than or equal to negative 9. So I'm asking myself, okay, is 0 less than or equal to negative 9? Is 0 less than a negative number? No, 0 is greater than all negative numbers. So that means I'm going to be shading above the line because this is a false statement. Okay, this is not true. So I don't want to include 0, 0. And then that means, it's a little bit hard to kind of see what's just orange, but this orange area is our solution set. Okay? Okay, so let's do a quick recap here. This is a really good image, graphic organizer, visual for you. So take a picture of this on your phone. On the left-hand side, okay, we're wrapping up systems of inequalities. So to graph inequalities, you're going to graph the line, okay? Get it in slope-intercept first. You're going to decide, am I using a dotted or a solid line? It's going to be dotted if your signs are just greater than or just less than. Okay, then you're going to shade. Okay, you can use your test point of 0, 0. Over here, I have a little example for you. Okay, so solve by graphing. The first thing, we've got to solve for y. We graph it, use our test point, and then this blue area would be your shaded zone, your solution area. Okay, so take a picture of that if you need it. And that is all I have for you today. So this is for 5.10. So if you want to go in and do the lesson and then take your quiz, you are free to do that. Also, before you leave, Thursday, your Unit 5 test is going to open. You can take it Thursday, or if you want to wait until after Thanksgiving break, you can wait on that. I'm going to put zeros in, but the week we get back from Thanksgiving, we're going to review. This is the last slide, Adelina. Did you want a different one? And then Friday, your Unit 5 writing assignment opens. So the reason I put the test in the writing assignment is because I know sometimes when you take a week off, it's like really hard to get back into things. Sometimes you forget things. So the Unit 5 writing assignment, which is due on Friday, is the last assignment for the semester. So you have the 5.09 quiz, 5.10 quiz, unit test, writing assignment, and you're done. Yes, I think I can. Let me figure out which one we did. There we go. Okay, on Friday at 10 o'clock in the morning, 10 a.m. Friday, I'm doing a help session specifically for the writing assignment. Okay, so if you have not done the writing assignment, or you did it, or you look at it and you're confused, please, please, please come to small group at 10 o'clock on Friday. Okay? All right, y'all. Have a good day.